Hello students, and welcome back to the next math review section. This is actually the last math review session of first semester, and it goes over the addition, subtraction, multiplication, and division of fractions. This will be on the next test and a significant part of your final exam. So I hope you have as much fun as I do through this. Let's begin. First, we're going to go over addition with a common denominator of fractions. So I know this is pretty basic, and you guys have probably seen this every grade since 5th grade, so I will go through it quickly, but it is good to have that background knowledge before you begin everything else. So my first example is 1/8 plus 2/8. Since I have a common denominator, my denominator being my lowest number on the fraction, I can add these together. When we add them together, our denominator does not change. It stays 8. My numerator is my top number, and we add these two together. 1 plus 2 is 3/8. 3/8 cannot be reduced, and in this review session and on the test, it is expected that you reduce every fraction, but since nothing can be divided by 3 and 8, 3/8 is your final answer, and I know it's very basic, but it's a good start. So, number 2, let's go 1/6 plus 3/6. Again, when I add these two together, my denominator does not change. 6 plus 6, I maintain the 6. I do add my numerators, however. 1 plus 3 is 4/6. Now 4/6 can be reduced because each of the numerator and the denominator can be divided by 2. When I divide 4 by 2, I get 2. 6 by 2 is 3. My final answer to 1/6 plus 3/6 is 2/3. The final one on the review session for addition with common denominators is 1/5 plus 4/5. I will give you a second to complete this and reduce this to the lowest common fraction. All right, again, my denominator does not change. I maintain the 5. 1 plus 4 is 5, so I have 5/5. Whenever I have a number over itself, my answer is going to be 1. The way I think about it is 5 goes into 5 1 times. 1 whole. 5/5, 1 whole. There you go. All right, so now we're going to get into addition with two fractions that don't have a common denominator. What you need to know for this is always you cannot add or subtract fractions unless you have a common denominator. So when you have unlike fractions, find a common denominator. All right, let's do some practice. So my first example, I have 3/4 plus 5/6. Now, I need to find a common denominator. These two are not the same. So I need to make them the same before I can add. There's two ways to do this. On this one, I know that 4 and 6 both go into 12. That is the smallest number that both of them go into. If I ever get stuck and I don't know what the common denominator is, I can't think what both of them go into, the easiest thing to do is take the two denominators and times them, multiply them. 4 times 6 is 24. For this problem and any others, you can use either of these for your common denominator. However, it's easiest to use the smallest number because that means you have less reducing at the end. So we are going to use 12 as our common denominator in this problem. The next step is I need to look at my two denominators. And I need to think to myself, how did I get from 4 to 12? Well, I know I did 4 times 3 is 12. So whatever I do to this bottom number, I have to do the same thing to my numerator. So I'm going to times 3 by 3. Because it was times 3 to get from 4 to 12, so I know I have to do times 3 at the top. 3 times 3 is 9/12. I'm going to do the same thing on the other side. How did I get from 6 to 12? Well, I know that I multiplied by 2. Whatever I do to the bottom number, I have to do to the top. So I know I have to times my numerator by 2. I have just found a common denominator, and now I can add. 12 plus 12 is not 12, but I keep my denominator the same. 9 plus 10 is 19, and I need to reduce this fraction. I need to put this improper fraction into a mixed number, since my top number is bigger than my bottom number. So again, I think to myself, how many times does 12 go into 19? It goes in 1 time, so that is my big number. The next part of this is 12 goes into 19 1 time. I think about how much is left over. So I would do 19 minus 12 to figure out what's left over. And that is 7. So that is my numerator. And my denominator, again, doesn't say the name. Stays the same. And so my answer is 1 7/12. If that last part kind of confused you, we're going to get into more how to switch into improper fractions into mixed numbers. So don't worry, you will get more practice with that. Your next problem, and I would like you guys to try this on your own, is 1/2 plus 4/9. Please pause the recording now and complete this problem. Remember, reduce your fraction into the lowest common form. All right, welcome back. We are having fun now. So my common denominator is, I can't think of what 2 and 9 both go into, so I'll just do 2 times 9 is 18. 18 will be my common denominator. So in order to get my numerator, I have to think myself, how did I get from 2 to 18? Well, I times by 9. Whatever I do to this denominator right here, I have to do to my numerator. I have to times that by 9 as well, because that's what I did to the bottom. 1 times 9 is 9. Forgot my addition sign. I'll look at my other fraction. How did I get from 9 to 18? Well, I times it by 2. And again, whatever I do to the bottom, I have to do to the top. So 2 times 4 is 8. Let's add them together. My denominator does not change. It stays the same. 9 plus 8 is 17. I cannot reduce this anymore. Nothing can be divided by 17 and 18, and actually 17 is a prime number, so I know that I am complete. That is how we add with unlike denominators. All right, here's where I'd like you to get some extra practice. There is an example up here. If you forgot while you're completing these problems how to find a common denominator and how to complete the problem, but for extra practice, I would like you to complete page 203, 1 through 8. Let's move on. Let's get into the addition of mixed numbers. So a mixed number is when you have a large number and then a fraction next to it. Let's start our first problem with 3 1/3 plus 2 4/5. Now there's a couple ways to do mixed numbers. You can change them into improper fractions and add and switch back, which some people prefer. I'm not going to teach you that method today. If you feel like that method's easier for you, feel free to use it, or if you'd like to come in, feel free to ask me how to do that. But today we're not going to go over it in this study session. So how we teach students to add mixed numbers to LMS is to deal with the big numbers first, and then deal with our fractions. So my big numbers are 3 plus 2. When I look at this fraction, it's actually, when I look at this problem, it's actually 3 plus 1/3 plus 2 plus 4/5. That is the same as 3 1/3 plus 3 2/5. So I like to deal with my big numbers first. 3 plus 2 is 5. I'm going to put that number over to the side, and I'm going to deal with my fractions now. But I have to remember that I have to add this number back at the end of the problem. So now I'm going to deal with my fractions. I have 1/3 plus 4/5. I cannot add this problem together because I don't have a, say it with me, common denominator. So 3 and 5, the lowest thing they can both go into is 15. There's my crooked addition sign. 3 goes into 15. I had to times 3 by 5 to get to 15, so I have to do the same thing to the top. 1 times 5 is 5. I had to times 5 times 3 to get to 15, times 3, so that is 12/15. And there's the minute bell. Okay, so again, my denominator does not change. I keep it 15. 5 plus 12 is 17/15. Now, since my fraction is improper, I have to put it into a mixed number. 15 goes into 17 one time. I think to myself, what is left over? So if 15 goes into 17 one times, 15 times 1 is 15. There's 2 left over to get to 17. And my denominator does not change, 1 2/15. This is lowest common form. Now, I have to take my fraction and add it together with what I found earlier when I added my 2 mixed numbers. So I have 5 plus 1 2/15. That gives me 6 2/15. There is a lot of steps to the addition of mixed numbers. But if you just remember to add your large numbers first, and then add your fractions together, and then to combine them at the end, you should be okay. All right. I am going to write one more on the board after I erase this, and I would like for you to pause the recording and complete it. Please try 8 4/5. Sorry, I know my writing gets progressively worse as we get through these study sessions. I'm even going to rewrite that for you. That is embarrassing. So I have 8 4/5 plus 5 8/15. Please pause the recording now and complete this problem. All right, back into it. So, again, I'm going to deal with my big numbers first. So, 8 plus 5 is 13. I'm going to put that number to the side, but I know I have to add that again at the end of my problem. And now I'm going to deal with my fractions. I have 4/5 plus 8/15. My lowest common denominator here is 15. Since 5 goes into 15, that is the easiest one to use, and that way we don't have to deal with very large numbers. I did 5 times 3 to get to 15, and I know I have to do the same thing at the top. That gives me 12/15, and this number over here did not change. 15 to 15, I did not change it, or you could think of it, I timesed by 1, times by 1, that keeps it at 8/15. 12 plus 8 is 20/15. 15 goes into 20 one time with 5 left over. And if you notice, and I hope you did, 5/15 is still not reduced. So that can be reduced to 1 1/3. That is the sum of my fractions. So I take the sum of my fractions, and I have to add it all the way back to the sum of my whole numbers. So 13 plus 1 1/3. I messed up down here. This should just be a 3. Sorry about that. 13 plus 1 1/3 is 14 1/3. And with me writing all over the board now, hopefully not confusing you, that is my final answer. If you got that answer correct, you are on your way to doing very well on the test. If you feel like you need extra practice, page 203, 18 through 24 is a great place to go for that. Bring it in to me if you're still unsure, and I will check over those with you. All right, that completes our addition portion of this review. Let's move on to subtraction. Subtraction has the same principles as addition. A lot of this should be review. You have to find a common denominator again, and instead of just adding the two numbers, we just subtract them. So I'm just going to start by giving you an example. If I have 1/2 minus 4/9, I cannot subtract this problem yet. I have to get a common denominator first. So again, 2 and 9, my common denominator is 18, and now I have to convert my fractions. Make sure you put the correct sign below. I see a lot of students who do everything right, just bring down the wrong sign, just kind of, a careless mistake, who get the problem wrong when really they shouldn't have gotten it right. So to get from 2 to 18, I times by 9, which is what I'm going to do at the top. To get from 9 to 18, I times by 2, which is what I'll do up here. And 9 minus 8 is 1. My denominator stays the same. 1/18 is my answer. Second problem, second example is 4/5 minus 5/8. Please pause your recording now. Whew, that 8 is poor. I'll try again there. Please pause your recording now and see if you can get this. All right. So this one may have stumped you a little bit, finding a common denominator. 8 and 5 have no common denominator until you get to 40. Again, if it stumps you and you don't know what to do, you can multiply the two denominators together, and that'll give you a common denominator. So I bring over my sign. Next, I had to think, how did I get from 5 to 40? Well, I multiplied it by 8. And again, whatever you do to the bottom, you have to do the top. So 4 times 8 is 32. Now, how did I get from 8 to 40? I multiplied by 5. When I multiply by the top by 5, I get 25. 32 minus 25 is 7/40, and I cannot reduce that any further. If you feel like you need additional help with the subtraction, remember the same concepts as addition, please go to page 203 and do numbers 9 through 14. All right. Now we are moving into what I believe is the most difficult concept in this whole review. This is the subtraction of mixed numbers. So again, it's the same principles as addition, but sometimes we have to borrow. And when we borrow, it kind of, it's a different way of thinking. I don't know if it's necessarily hard, but it's a different way of thinking. So what I did for this is I gave you specific directions to the side while I'm going through this, so you don't have to try to read my writing in order to help out. All right, let's solve this problem. So when I have 6 1/2 minus 2 6/7, again, I have to find a common denominator first. In subtraction, I don't recommend that you deal with your big numbers first and then you deal with your fractions. I actually recommend you deal with your fractions first. It's a little bit different than addition, but I think it's easier to borrow. So I'm on step 2 now. So I have to find a common denominator. So my common denominator between 2 and 7 is 14. I got from 2 to 14 by multiplying by 7. I got from 7 to 14 by multiplying by 2. I have 7 minus 12, 6 and 7/14 minus 2 and 12/14. Now, you'll notice a problem with this. When we subtract, we cannot subtract when the top number is smaller than the bottom number. In normal subtraction, we would borrow. we are going to borrow right here. So I'm going to borrow from the large number, which is the 6. The 6 becomes a 5. I'm on step 3. Okay. Now, here's the step that confuses people. Instead of adding a 1 to the 7, which is what we generally do, I have to add what the denominator is. So here's the rationale behind that. In this problem, I have 14 small ones. I think that's 14-ish. 1, 2, okay. I have 14 little pieces that make up one big whole number. So when I take away one big whole number, I have to add these little 14 pieces back into the numerator. So I have to add 14 to 7, which gives me 21. And then I can do my problem. 21 minus 12 is 9/14. And 5 minus 2 is 3. I cannot reduce that. That is my answer. So this one I would add it 21. And it is in simplest form. There are your steps. We're going to do another practice. Remember, when you borrow, you have to add what the denominator is to your numerator. It's those little pieces you have to add back in, the little pieces that make up the whole that you have to add back in. Here's another one. So, we're organized. Let's find we do have a common denominator. Wow, this one's much easier. So, we have to borrow, because I cannot do 1 minus 2. The top one is bigger than the bottom one, so I'm going to have to borrow. I'm going to borrow from the 3, and the 3 becomes a 2. All right, here's your million-dollar question. Since I borrowed, what does the 1 turn into? It turns into a 5. I have to add the denominator. Since I took away one whole one, I have to add 4 parts to the 1, which gives me 5. 5 minus 2 is 3. 4, 2 minus 1 is 1. That is in simplest form. There you go. I would like to give you one practice one right here. So let's try 6 5/8 minus 1 3/4. Please pause your recording and complete this now. All right. So I have to begin, as always, by finding a common denominator. I'm just going to write it to the side over here. I'm not going to subtract my whole numbers. So my common denominator is actually 8. Since 4 and 8 both go into 8, I can keep this top one the same. This becomes an 8. I times 2 over here to get to the 8. So I have to times 2 by the top. 3 times 2 is 6. All right, here's my problem. My top one is smaller than my bottom fraction. So I have to borrow. I'll borrow from the 6, which becomes a 5. And I add in an 8 to the 5, which becomes a 13. I add an 8 in because there are 8 small pieces to the whole. 13 minus 6 is 7. 7/8. 5 minus 1 is 4. 4 and 7/8 is simplest form. There you go. If you got that correct, congratulations, you are on your way. Since this is a difficult topic, if you feel like you didn't understand this part of the study session, please come see me. And I will give you some more problems, and I can work through some of these with you and kind of the concept of borrowing. All right. So we are going to get into multiplication now. I love multiplication and division of fractions, and I'm sure you guys will too. It is the rare occurrence where the multiplication and division are much easier than the addition and subtraction. So we will come back. There we go. There, now I'm on my right side. So let's do the multiplication. So in my first problem, I'm going to do 5 6 times, what do I want here? Let's go 1/4. Now, multiplication and division, you do not need a common denominator. Let me say that again. You do not need a common denominator for multiplication and division, only addition and subtraction. So, in multiplication, the first one I'm going to show you, all we have to do is multiply across, and you have your answer. 5 times 1 is 5. 6 times 4 is 24. We still have to reduce, but this problem cannot be reduced. There's your answer. Very, very basic. Another one. Now, I would like to teach you a trick. So if I have the problem 3/16 times 8 over 1, this is called cross reduction. If you master cross reduction, your life becomes extremely simple and you do not have to reduce hardly at all. So when I cross reduce, I look at the fractions across from each other. There's an across and there's an across. Now, when I look crossways, I see if either of those can be reduced or divided by the same number. 3 and 1 cannot be reduced. 1 is already in its simplest form, so we don't need to reduce that. However, 8 and 16 can be. Both 8 and 16 can be divided by 8. So I can divide this by 8, and I can divide this by 8. 8 divided by 8 is 1. So I can just actually cross this 8 out and put a 1. And I can cross this out and put a 2, because 16 divided by 8 is 2. So now, after I cross reduce, 3 times 1 is 3, 2 times 1 is 2. When I simplify that, I get 1/2. Cross reduction makes your life very, very simple. I'm going to erase this right here. And I would like you to pause your recording and try 9/10 times -2/3. Please cross reduce here. You may pause your recording now. All right. So when I look across, I notice that both of these can actually be reduced. Both 3 and 9 can be divided by 3. When I divide 3 by 3, I get 1. When I divide 9 by 3, I get 3. This one right here, both can be divided by 2. When I divide 2 by 2, I get 1. When I divide 10 by 2, I get 5. Now I can do my very, very simple multiplication. 3 times 1 is 3. 5 times 1 is 5. Your life is super easy, no reducing. I can't believe how fun this is. If you need extra practice, there are the problems to complete, and come show me. Now, back to this slide. So we're going to get into the multiplication and division of mixed numbers. In order to multiply and divide mixed numbers, you have to put them into improper fractions. So here's how you put a mixed number into an improper fraction. First, you multiply the whole number, this is the whole number, times the denominator. So I would do 2 times 3. Then you add that answer to your numerator. So 2 times 3 plus 1. 2 times 3 is 6. 6 plus 1 is 7. And step 3, you put that sum over your denominator that has not changed. 7/3. That is how you change a mixed number into a fraction. So let's practice multiplying some mixed numbers. If I have 1 and 1/2 times 2 and 2/3, I need to put both of these into improper fractions before I begin. So let me grab a different color for this. 1 times 2 is 2, plus 1 is 3. So that gives me 3 over 2 for this fraction, and I times that. 2 times 3 is 6. 6 plus 2 is 8/3. Now I look across to see if I can reduce anything before I multiply. 8 and 2 can both be divided by 2, which gives me 1, which gives me 4. 3 and 3 can both be divided by 3, which gives me 1 and 1. Now I can multiply. 1 times 4 is 4. 1 times 1 is 1. And when I reduce this, 1 goes into 4 times. Or if you ever have a number over 1, that is your answer. And 4 is my answer. All right, I would like you guys to try this problem. Please try -8 times 1/4. Remember, when you have a big number by itself, it goes over 1. Please pause your recording and go ahead. All right, so we have -8 over 1. This is not a mixed number, but you know what? We'll get some more practice with those. So look if I can cross-reduce. These two can be cross-reduced. Both can be divided by 4. That gives me with 1 and 2. -2 times 1 is -2 over 1. And my answer is -2. If you need additional help, page 208, numbers 8 through 12 are the place to go. And I will check those over if you would like. Okay, so now we're into the division. You cannot divide fractions. Let me say that again. You cannot divide fractions. Instead, what we do is called multiply by the reciprocal. So up here is my division vocabulary. All you need to know is the word reciprocal. Reciprocal just means the inverse or opposite. So when I say multiply by the reciprocal, I'm going to have you flip the second fraction or the fraction that you are dividing by. So if my fraction is AB, I'm going to have you flip it into BA. I know that's a little abstract using letters, but you will I'll give you an example right now. All right, so here's just a quick organizer that I created just to show you how to divide fractions. So our first step is that we multiply by the reciprocal. So if I had the fraction 4/5 divided by 2/3, since I can't divide, I keep my first fraction the same, 4/5, and multiplying by the reciprocal, I flip the second one. 3 over 2 instead of 2 divided by 3. Multiplying by the reciprocal, and now I can complete the problem. The second step, as always, is just to multiply across or see if you can cross-reduce, and then your final step is to reduce. So remember, you cannot divide fractions. Instead, we multiply by the reciprocal or flip the one that we are dividing. All right, so here's your first one. I will demonstrate it for you. So if I have 1/2 divided by 5/6, I keep my first fraction the same. 1/2, and then I have to multiply by the reciprocal. Times, I flip the second one, 6 over 5. Excuse me. Before I do this, I can cross-reduce. So 2 and 6 can both be divided by 2. That gives me 1 and 3. When I multiply across, that gives me 3/5. And my cool little organizing thing, there we go. Nice. Gives me an answer of 3/5, but it gives it in more detail. All right. Next problem. I think you guys can go off on your own on this one. Please remember to multiply that by the reciprocal, and you may pause your recording and go ahead. All right, I am just going to move this down. You'll notice that they flipped the second one. Instead of divide by 1/4, they had times by 4 over 1. And multiplied across. 3 times 4 is 12. 1 times 7 is 7. Put that back into a mixed number, and there's your answer. All right, last practice problem. So 2 divided by 2 and 2/3. Please pause yours. Remember, if you have a big number, it goes over 1. And complete this problem. Okay, I'm going to move this down for the answer. So instead of doing 2 divided by 2 2/3, I have 2 over 1 because this would have gone over 1. Let me get a darker pen for you. This would have gone over 1. 2 over 1, and then I flip it. I multiply by the reciprocal, which gives me 2 over 1 times 3 over 2. I did not cross multiply here, but if you would have, you could reduce this, and that would have given you your final answer of 3 right away. This up here, I kind of showed you the long way, just multiplying across, but I'd prefer that you cross-reduce. All right, so here are a list of practice problems. Please pause your recording and go ahead. I will, since I've shown you 3 already, I will not waste your time with showing you all these. I will just put all the answers up when you are done. You may hit play again. Go ahead. All right, and magically all your answers have appeared. The first 3, I gave you the work next to it just so you could check yourself, and then after that I just gave you the answers. This last one is supposed to be underlined. There it is circled, 3/4. All right, pause it if you need to check them over. If not, let's move on. All right, so the final part to this study session is trying to figure out which fraction is larger. I didn't have this in the intro, but this is kind of a big part of the test as well, and I did it in a nice little relevant canned food drive, which is going on right now, word problem. So if my class, Mr. Slade's class, has reached 2/5 of its quota, and Mr. Shaw's class has reached 5/11, we have to figure out who's closer or which fraction's bigger. All we have to do is find a common denominator to see which fraction is bigger. So if I have 2/5 and Mr. Shaw's has 5/11, we have to find our common denominator. I cannot think of one, so I'm going to do 5 times 11 is 55. 55. My class I timesed by 11 to get from 5 to 55, so I have to do the same to the top. 2 times 11 is 22. Mr. Shaw's class, to get from 11 to 55, he times by 5, times by 5. 5 times 5 is 25. I see that Mr. Shaw's class is closer, and that 5/11 is indeed bigger than 2/5. Just a quick little add-on for you, because on the final it'll say, which fraction's bigger. That will help you out. So if you feel like you need to do some practice with that, page 198, numbers 1 through 6 are the place to go. This concludes our review session. I hope that you had as much fun as I did during this. I would like to see some of your problems, check them over with you upon completing this, and my information, including my school phone number and email, are up here. So if you need anything, please let me know. Thank you very much for joining me, and you will do great on your test. Mr. Slade loves you. Have a great day.